Hi guys, do you know how polarity affects in our life? Okay, look at for this example. I have tried to mix oil and water for 6-7 times, but I still couldn't make it. However, how can liquid combine and react together?
Oh, that's the reason of polarity. Polarity exists in our life everywhere. So, what exactly is polarity?
Polarity is describing as the sharing of electrons between atoms. Before we move to the topics, let me introduce ourselves. My name is Alif
My name is Rais,
and we will be your
chemistry talk show host
for today. So without wasting more time, let's get straight to the topics.
And the topic of discussion for this week is
Polarity. Since we'll be discussing about polarity, let's first watch this short animation slide.
Electronegativity is the ability of an atom to attract shared electron toward itself. If an atom has higher electronegativity, it pulls the bonding electrons closer to itself. Electronegativity can be determined using periodic table. It increases from left to right across the period and decreases from top to bottom down the group.
Usually, polar substance dissolve in water. Water has positive and negative ends and is a polar molecule, so it attracts and dissolves other polar substances. By using this idea, we can identify polar substances. This unequal sharing of electrons creates a dipole. A dipole is shown using an arrow, and the arrow always points towards the more electronegative atom. Each polar bond has its own dipole moment.
Moving on to bond polarity and molecular polarity. Bond polarity is about one bond, which means how equally or unequally electrons are shared between two atoms in that bond. Unequally sharing of electrons will produce non-polar covalent, while equally sharing of electrons will produce polar covalent. Molecular polarity is about the whole molecule, which means it depends on all the bond polarities and the shape of the molecule.
This is where cancellation becomes important. Cancellation means the pulling effects of the bond balance each other. If the pulls are equal and in opposite direction, they cancel out. When this happens, the molecule is nonpolar. If the pulls do not balance, then the molecule has one side that is more negative and one side that is more positive. In this case, the molecule is polar.
Hi guys, I'm Cl atom. Hi guys, I'm Cl atom.
These two atoms have the same electronegativity. Both sides pull the string equally, the string stays in the middle, there is no stronger pull on either sides, so the bond is non-polar. Now, look at HF.
Hi, I'm fluorine atom.
Hi, I'm hydrogen atom. Fluorine is more electronegative than hydrogen. You can see the string is moving closer to fluorine. This shows the dipole movement from hydrogen to fluorine. Fluorine becomes slightly negative, whereas hydrogen becomes slightly positive. The unequal pulling creates a polar bond.
Here's the part of our short demonstration. I hope this enhances your understanding. It's the end of the show now. Before the ending, may anyone share your opinion on how polarity presents in our real life?
Is widely used in real life, such as hand sanitizer and perfumes, which is one of the examples to represent the polar reaction.
Exactly. Ethanol contains a hydroxyl group. Oxygen is more electronegative than hydrogen, so it pulls the shared electron more strongly. As a result, oxygen becomes slightly negative and hydrogen becomes slightly positive. These unequal sharings of electrons make ethanol a polar molecule, allowing it to mix easily with water.
Nice explanation. So, how about non-polar substances? Here's a tip. We have talked about it at the beginning of our show.
Oil is nonpolar. Oil is made of atoms that have same electronegativity. It has equal sharing of electrons, no charge ends, so it cannot attract water molecules. Hence, oil does not mix with water.
Exactly. It seems like you all can understand the concept now. So, that's the end of our show. Thanks for listening. I'm Rais and
I'm Alif.
see you guys next week.
Bye.